All right, so let's next look at our series 1 over 2 to the n minus 1. We've just been talking about the comparison test. All right? So on the comparison test, this is our a sub n, right? And so I want to compare that to a series b sub n, which, how do I usually make the b sub n? Do the leading term, so it'd be some 1 over 2 to the n, which we know a little something about that. What kind of series is that? It'd be exponential, won't it? A geometric, it's an exponential expression, so that's a geometric, and it is convergent because r is 1/2. Yeah, the r is between -1 and +1, so it's convergent. Okay? But also in the comparison test then, since my b sub n is convergent, what do I need? How do I need the a sub n's to compare to the b sub n's? Well, we need those to be less, right? Less than or equal to. Is that true? It is? 1 over... well, let's compare them here. A sub n is 1 over 2 to the n minus 1. B sub n is 1 over 2 to the n. Now, we haven't talked about other ways. Right now, we're just looking at the denominators, aren't we? This denominator would be smaller than this denominator. It's smaller, okay? So how does this compare to that? We've got 1 over a smaller number, so that's going to be bigger than that, isn't it? Uh-oh. No good. This is not good. So what that means is, since the a sub n's are bigger than the b sub n's, and I've got convergent b sub n's, now if the b sub n was divergent, that's what we would want. But the b sub n's are not. They're convergent. So what does that mean? This means we can't use the comparison test. Comparison test fails. All right. So we have to do another, just like before, if we ran into difficulties on this particular test, we just have to do another test. Okay? So we have to punt, as they say. All right. Well, the one we're going to use on this is one we haven't talked about yet. So let me talk about that, and then we'll come back to this. Okay? There is another test known as the limit comparison test. Limit comparison test. It also compares two things, a sub n and b sub n. But here it goes. All right, suppose series of a sub n's and the series b sub n's are series with positive terms. If the limit as n goes to infinity of a sub n divided by b sub n is equal to c, where c is some positive constant, is a finite number, let's say it this way, is a finite number, and c bigger than 0. If that's true, if we get the limit equal to a number, a positive number, greater than 0, finite positive number, not infinity, not negative, positive, finite. Okay. Then, here's what you can say. Either both series converge or both series diverge. Now, how would that help us? Well, that helps us because usually, what do we know about B sub n? We know, because of the way we construct it, we know whether B sub n converges or diverges, right? So if we do this limit, so it's the limit of the A sub n's divided by B sub n's, if that equals some positive constant, a finite number, then whatever B sub n, A sub n does, basically what it amounts to. If B sub n converges, so does A sub n. If B sub n diverges, so does that series A sub n. Okay? So it's a nice, another nice thing to do. Well, this actually helps us then. So let's go back to the series. What was it a while ago? 1 over 2 to the n minus 1. All right, let's use the limit comparison test on that. Okay, well, on the limit comparison test, we're going to do the very same thing as we do with the comparison test. I'm going to, that's my A sub n right there. And so the series of the B sub n's is going to be the leading terms, if you will. So again, we know that is a geometric series that is convergent. Right? We still know that. Okay? How far can I go? Okay. Just to my G there. Okay. So this one's geometric. R equals 1, so it converges. All right. Well, now for the limit comparison test, we got something about B sub n. We compare it to, now we take the limit of the A sub n's. So I'm going to look at the limit as n goes to infinity of the A sub n divided by B sub n's. That's where I change this up. I look at a new limit. All right, so I'm going to take 1 over, do the limit as n goes to infinity of 1 over 2 to the n minus 1. Divide that by the B sub n, which is 1 over 2 to the n, right? See what happens there. Well, this isn't too bad because, as we know, this divided by that means 1 over 2 to the n minus 1 times the reciprocal of that. With me there? Isn't that what that means? 1 over 2 to the n minus 1 divided by 1 over 2 to the n means 1 over 2 to the n minus 1 times 2 to the n over 1, right? Times the reciprocal of the denominator. Well, that is just the limit as n goes to infinity, 2 to the n over 2 to the n minus 1. And there's different various ways of evaluating that limit, but here's one way. What if I do this? I don't think we've ever done one exactly in this format, but what if I divide both top and bottom by 2 to the n? Well, doesn't that get me the limit as n goes to infinity of 1 over 1 minus 1 over 2 to the n, which is a pretty nice little limit, isn't it? That's an easy limit. What's the limit of that? 1 over 1 minus 0. That goes to 0, right, of course. As n goes to infinity, that goes to 0, right? Is 1. Now, does this tell us anything? Well, if we get this equal to a number, basically it doesn't equal infinity, or negative, I guess, too, but yeah, it tells us something. So this is a positive C number, a finite number that's positive. So that limit equals a finite number that's positive. What does that tell me then? Either both series converge or diverge. Well, I know B sub n series converges, so what about the A sub n? Converges also. So both series do the same thing. I know B sub n is convergent, so A sub n also converges. Okay? By the limit comparison test, LCT. All right, here is another. Okay, let's use the LCT. For the series 2n plus 1 over n squared plus 2n minus 1. All right, this also is a good candidate for the limit compare. Let's just talk about why this would be a limit comparison test as opposed to a comparison test. Well, the reason would be it's going to be hard to tell whether or not this right here is less than or equal to something else because you've got just a whole lot of stuff going on. So this one's probably not a good one for comparison test because it's so complicated there. So anyway, limit comparison test is what we're going to do. All right, so that's my A sub n. So what do you think B sub n is going to be? B sub n series is, well, do the leading term thing. 2n over n squared, right? Which is 2 over n. What do you know about that series? Divergent y. That's harmonic series, yeah. Yeah, anything just over n is a harmonic series. 2 over n, 3 over n, 100 over n, and it's positive. So we're all good here. So now what do we look at for limit comparison test? Then we look at the limit as n goes to infinity of the A sub n, 2n plus 1 over n squared plus 2n minus 1, divided by 2 over n. Well, that is the limit as n goes to infinity of 2n plus 1 over n squared plus 2n minus 1. But it's since that's 2 over n, that would be times n over 2. If we bring it up, so to speak. Which gets me the limit as n goes to infinity, 2n squared plus n. I'm just distributing my n there, and then I'm going to distribute my 2 there, so it'll be 2n squared plus 4n minus 2 on the bottom. Everybody with me there? So far, so good. Okay, well, that limit we can do real simple here, divide by n squared, top and bottom, right? So that'd be the limit as n goes to infinity of 2 plus 1 over n over 2 plus 4 over n minus 2 over n squared. So that's 2. The limit would be 2 plus 0 over 2 plus, what happened here? It's 4 over n, sorry. 0 minus 0, so that's 2 over 2, that's 1. Same thing we got over there. So again, this number is a finite positive number. So that's good for the limit comparison test, right? Yeah. If that limit is a finite positive number, then both series do the same thing. Well, both do the same, so if B sub n diverges, series, so does the A sub n. Okay? One more for you here for this limit comparison test. All right, let's use the limit comparison test for this series. 100 plus 3n over n cubed plus 2. Okay. So we want to, okay. So That's a sub n. So the b sub n is going to be 3n over n cubed, right? That one divided by that one. So that's 3 over n squared. What do you got on that? Convergent or divergent? Convergent, why? P series, P equals 2, right? Yeah, so when you're doing these things, I would like for you to tell me convergent or divergent and tell me why you're saying it's convergent or divergent along the way. So just so I know, you know what you're doing. Okay? Instead of just guessing. All right. So for limit comparison test then, let's look at limit as n goes to infinity of a sub n divided by b sub n, which is going to be, in this case, limit as n goes to infinity of 100 plus 3n over n cubed plus 2 divided by 3 over n squared. What happens there? Well, same trick every time. Move that up, do the reciprocal thing. So let's see. Comes out pretty nicely, doesn't it? It's 100n squared plus 3n cubed divided by 3n cubed plus 6. Do the divide by n cubed thing here. That's what I got on the bottom, biggest power. So wind up the limit, n goes to infinity. 100 over n plus 3, 3 plus 6 over n cubed. That's 0 plus 3 over 3 plus 0. It's 3 over 3, that's 1. Could get a different number than 1, but we've got 1 3 times here now, but we'll probably come up a lot. But anyway, all right. So again, we have positive, finite, just what we need for this test to work. Both series do the same thing then. B sub n converges, so A sub n converges. Okay?